Okay. So today we'll discuss about virtualization and containerization. All these days we use the virtualization itself. Okay. So what is the concept of the virtualization is like before virtualization we have the physical servers, and those physical servers we move to hypervisors, and from the hypervisors now we are using cloud instances or maybe Azure VMs. Those also is technically virtual machine itself, because even in the cloud also the backend what's happening is we are getting a virtual machine itself. What is the concept of the virtualization is, on the one physical server we are going to install multiple virtual machines, okay, using the hypervisor. Okay, so using the hypervisor, and we have two types of hypervisors, like type 1 hypervisor or bare metal hypervisor, and type 2 hypervisor or hosted shared hypervisor. And we can use VMware ESXi server or Hyper-V or Gen server, Gen source, Oracle virtual server or Oracle virtual box, KVM. Okay, any of these hypervisors we can use. But in the host is called as that physical server, and what is that guest is? The guest is a like that instance or virtual machine we are calling. Okay, and that guest is having the complete full operating system it is running. Say we took the Windows server or Ubuntu, like this here we are going to use either in the cloud also we are getting the virtual machines, or even in the like in the hypervisors also we are getting the virtual machines. What is the advantage of this virtualization? What is the advantage of virtualization? So we no need of more physical servers. One physical server
Cost
resources
effective.
itself can be shared. One physical server resource itself can be shared. Okay, and that physical server, here we are going to share is like the physical resources like CPU, memory, network, storage, all those are getting running, and it's provided the isolation also. That means one VM doesn't have any impact on the other VMs. Okay, so we are getting the isolation also we are going to getting. Okay, then here we have like one hypervisor is there, maybe KVM or Gen source. On that we have the guest multiple operating systems are running. Okay, different operating systems like on the same hypervisor, we can run different operating systems also. One Ubuntu, one Red Hat, one CentOS or one Windows. Like this also is possible. Okay, so that is the advantage. Then here now we have a new concept, even in the cloud also without knowing to us, we are using virtualization itself, because all those running as the VMs itself. Then now we have a new concept which is leading the market as of now for the deployment. Those are called as containerization. And on top of that, we have the container orchestration also we have. Okay, so for the containers, we have Docker is one of the leader, and for container orchestration, so
Kubernetes.
Kubernetes is the leader. So now here we need to understand, all these days we have used the virtualization. Then on top of that, we are getting the containerization. Then what are the differences between virtualization and containerization? We need to understand. So in the containerization, like we are not running the full operating systems. We are getting a lightweight OS we are running on the Linux or Windows or Mac also. Instead of the full VM, we are going to use the tiny containers, or maybe a lightweight version of the OS we are running as the containers, and we are going to deploy our applications as the microservices we are going to deploy as the microservices we are going to deploy. And what is the main advantage is, those containers are very lightweight. Those containers are very lightweight. Okay, the physical mission will take more time to load, whereas the containers will have the kernel kind of features like Linux, all those, but those are very lightweight. But those are very lightweight. With this, what is the advantage is, the containers can be loaded very fastly. the containers can be loaded very fastly. Those are going to load. Okay, so then in the milliseconds also it can start, whereas VM will take minutes, maybe 3 to 5 minutes. We are getting an instance, and that application also will take more time to start. Okay, so whereas containers are like for the real applications, these are like suits for the current trend. Okay, yeah. Any doubts on this? Any doubts? So here the scenario is, all these days we use the virtualization. Virtualization like will use the full operating systems it will consume. Okay, so then on top of that, like we are going to use a lightweight we are going to use, and here we have two concepts like namespaces and C groups. These are the Linux concepts I will explain, because containers on the Linux are going to use namespaces and C groups. So those all we are going to discuss. Okay, so then, so now here we have uh, like comparison between virtualization and containerization. In the virtualization, what's happening is full guest OS per VM, whereas in the containerization, what's happening, that OS says, suppose even we have a single server. I'll explain one use case. We want to install, assume we want to install Tomcat, okay, then 8, 9, 10 on the three servers. If I want to say, if I want three versions of Tomcat, Tomcat 8 I want, Tomcat 9 I want, Tomcat 10 I want. Then if it is the instances or VMs, I need to take three VMs, because on Tomcat 8, okay, if I start installing Tomcat 9, it will upgrade to Tomcat 9. All the three versions simultaneously I can't maintain. But if I use the containers, what I can do is I can maintain Tomcat 8 as one container, Tomcat 9 as one container, Tomcat 10 as one container I can maintain. In this use case, how many like kernels we are going to use? The host kernel is only one, but in that we are running three different containers. But we need to go for in this use case, we need to go for three VMs we need to go. So we need to go for the three VMs we need to go. So that is the major difference. We no need of more servers also. Okay. If I read three VMs again, I want the hypervisor also is required for hypervisor also. Say suppose here fully guest operating system, like here in this use case, I want three VMs, but in this one host OS kernel itself shared by three containers, and that VM startup time is minutes, whereas in the containers it would be seconds or milliseconds only is going to do, and which is lightweight.
Containers.
Containers are lightweight, and hardware level isolation is strong with the virtualization. We'll discuss this also, and portability also. Here we can run anywhere. Okay, we can run anywhere. Okay, and for modern apps and microservices, containers are best. If you have the legacy apps, are like better to go with virtual machines. Okay, so then here, which is recommended to use for the modern apps? For microservices also, VM is not recommended. Now, assume here we have a very high-end physical server. On that, we are installing the hypervisor. On top of that, I'm going to install multiple operating systems. Okay, so in this use case, how many operating systems I have installed? Three. Even 100 also we may install if that hypervisor hardware supports. But what is the challenge is, I want the hardware, I want the hypervisor is required. But if I go for the containers, this is only one operating system. That means this one guest operating system. Here, how many VMs are there in this three VMs, right? In the single VM itself, we can install a Docker kind of container engine, and three containers can be running. But in this use case, how many VMs I want? How many VMs I want? I want 3 VMs. Okay, so that is the challenge with the virtual missions, and that takes more time also to load it. Okay, so in order to deploy the modern microservice kind of applications, which one is the best method?
Containerization.
Yeah, containerization is the best method we are going to deploy. Containerization is the best method. Okay. So what are the advantages of containers over virtual machines? One is lightweight. Okay. We no need of the complete operating system that reduces lot of memory and storage usage. And the hosting infrastructure also can be reduced. And we can deploy our high scalable applications. And another advantage we are going to get is the startup time is within the milliseconds to seconds itself, whereas like with the VM it is taking minutes, because the complete operating system need to start there. The complete operating system need to start up. Okay, so then like here portability, say containers easy to run on the multiple versions, also easy to run it. Okay, so previously like we have a lot of dependencies. Red Hat doesn't run some apps, or Ubuntu package names are different. We have a lot of compatibility issues. Okay, and we can run the same container on the different environments also, like Dev, QA, and we can make it cloud native also for the multiple clouds also. We can make it cloud native kind of thing. Okay, and easy to integrate with the CI/CD pipelines also. Easy to integrate. Okay, so then we have a lot of advantages, and one more advantage is scalability. It's a very easy to scale up also, and scalability even in the VM level also we can do auto scaling kind of things, but that application will take more time. Okay, and that replication also will take more time. But today in the market, to catch the speed of real applications, scalability, containers are the best one. For that, we are going to use microservices, and microservice scalability is going to be done through orchestration kind of tools like Kubernetes. In that scenario, microservices as the containers, if they're running, they can scale up very fastly, and they can scale down also very fastly. Okay, with the VMs, that time will take minimum 5 minutes, and today that is not matching the current requirements. Okay, so even the scalability is also one of the good feature of scalability also is one of the good feature of
Containerization.
containerization. That is not that much easy with the virtualization. Okay, and we have security wise virtualization having more benefits compared to containerization. We'll discuss. Okay, so then here what is the main advantage is like it's easy to boot, fastly it's going to boot, scalability, portability, stackability we are going to get, and even it's very cheaper, compatibility also, like portable kind of things also we have with the containers. Okay, whereas with the virtualization, like here resource usage is more, portability is moderate, performance also like slower. Okay, so then scalability also will take more time, cost is higher, but these all the challenges can be avoided by containers. So we have a lot of advantages with the containers, right? We'll discuss some considerations or disadvantage. Compared to the hypervisor, I'll tell one example. Say suppose in the AWS, one instance got affected, it doesn't affect other VM, or it doesn't affect the physical host machine also. Okay, but sometimes if the host is compromised, other apps also may be affected. Okay, but that is not possible with the virtualization. Even one VM affected, or host mission affected also doesn't have any impact on the VM. Okay, but here in the containers, those are sharing the host OS kernel. That is the reason if that host kernel is affected, okay, then even the containers also will have the impact. Some standards, like maybe some security kind of standards we need to follow. Okay. Then here even sometimes at process level, if it is like kernel exploits or maybe more attacks, that is the reason we require a lot of scanning for the container kind of things. But whereas what is the main advantage is VM will provide more hardware level isolation. That's not possible that much with the containers. That's not possible with the containers. And sometimes like Linux containers, if say suppose I want to deploy a Windows like maybe .NET Core application, I may deploy in Linux. But if it is normal .NET application, I want a Windows kernel. Okay, Windows kernel doesn't support Linux. Linux doesn't support Windows. But Linux different versions we can run it. Okay, like we don't have any compatibility issues like Ubuntu, Red Hat, CentOS like this. But if you have any Windows specific container requirements, then we need to use Windows container itself. Even that is there with the virtualization also. And previously, we don't have limited monitoring and debugging tools, but now we have lot of tools like now we got the capabilities. Maybe 10 years back, like when containers came into the market is around 2012, 2013, they came into the market. At that moment, normal traditional monitoring tools doesn't have the capability to collect metrics at the container level. But today we have very powerful solutions to collect the metrics and for the logging also. Okay. Previously, we have that challenge, but today we have a lot of powerful solutions. And storage wise, the data is not by default persistent. What is that meaning is, if my container is stopped or if my container is deleted, I'm going to lose my data. Okay. But like we have a solution for this also. We are going to attach the volumes. By attaching the volumes, what is going to happen is, even if the container is stopped or maybe deleted also, the data inside the container is the
Existing.
data inside the container is persistent. Okay. And we need to understand container networking, all these also, like little learning wise, little challenging, but that's itself is going to use in the today real microservices or modern applications. We are going to use this itself. That is the reason we require to learn all these tools. For stateful applications also in the Kubernetes, we have the solutions we'll discuss. So maybe more containers, what it required is, if you have the hundreds or thousands of containers, we may have or some millions of containers also we have in the real time that required orchestration kind of tools like Kubernetes. But we need even Kubernetes knowledge also. That's not a disadvantage kind of thing. That is creating new job opportunities for us. So hence we should have good learning curve over the Docker and the Kubernetes. Then we can build our career in this. Okay, and even to go for the Kubernetes also, Docker is the prerequisite. Okay, so some legacy kind of apps and those may not support the containers. Okay, but today that's in at that moment better to go for VMs itself, because even in the cloud also some compliances may not support to use the legacy applications. That's kind of systems better to run in the
Virtual.
virtual machine on premises itself. Maybe cloud also maybe not that much compatible for those.
Like what, sir?
So those are the very legacy kind of applications that standards not allowing us in the cloud or maybe in the containers to run that.
Okay. Like example for
Like
legacy.
example is maybe old mainframe kind of systems. Okay, those are security wise. Say suppose I'll tell one example. WhatsApp doesn't support old Android versions or iOS versions because compliances wise, security wise, risky to use those devices.
Okay. Okay.
So like this here, I have very old applications, old systems. Those are not supported now with the say we have MS-DOS or maybe IBM older version softwares. Those are not recommended to use in the cloud. because those open the vulnerabilities, and for others also it opens threats, ransomware. These kind of attacks may happen more on those devices. Okay, so those kind of legacy apps not recommended to move to cloud or maybe microservices, not recommended. We need to re-engineer them and make them as the modern apps, then better to migrate. Okay, so now here containers, we have the weaker isolation compared to VMs, and vulnerability and security wise exploits. That is the reason lot of scanning is required in that. Lot of scanning is required. So that's the reason we need to scan those images very properly, and lot of scanning, multiple tools we need to integrate with the scanning. After that scanning approvals itself, we need to move into production. Okay. So then persistent storage, anyhow in the EC2 also we have the EBS volume, right? In the same way, even for the containers also, we need to attach Docker volumes. And in Kubernetes also, we need to attach PV and PVC. Okay. So then network wise, little complex, but that's networking also we need to design for our applications. Developer can't do this persistent storage, networking kind of things. That's giving more job opportunities for us in the DevOps. If the developer itself is able to do all this, then we don't have the job opportunities. It's little complex. We need to understand and we need to design the solutions. Then, additional to the developer, we will also have the career opportunities. Okay. So scalability, like we require the orchestration kind of tool. And even in the hypervisor also, we want auto scaling kind of features, load balancing, all these we need to integrate. Okay, so now what is the solution, like what is the concept which is supporting containerization on the Linux? Okay, so that is called as Linux namespaces and C groups we have. Okay, so now here on the Linux mission, in order to run the isolated containers, we have one concept called Linux namespaces and C groups. These are the Linux kernel features. These two features itself are supporting to run the multiple containers. Say just like we have a very big like floor is there, but what container we are isolating that by dividing them into multiple partitions or rooms kind of thing. Even the Linux server also, we are creating an isolated environment. Okay, so then here we are logically isolating that system resources for each process. That's Linux namespace will do. The process level isolation is going to be performed, and on the same Linux server, multiple containers can run, and their own, say suppose if I have four members, I given four rooms for them. Everyone are staying in those four rooms. Okay, but sharing the same flat. But here, previously we have the different flats, but now here we are going to share the same flat, but they have their own isolation, how they are getting the privacy, all those. They have their own four rooms. We have these kind of in the Linux machine also. We have the Linux namespaces, which will provide us process level isolation. Okay, so then we have the different type of namespaces in this process level isolation, network level isolation, resource level isolation. Okay, and C group level also. Then what is the concept of C group is, we are going to limit the resources more than this you shouldn't use. So maybe say suppose even when we are constructing apartment also we'll have 1200, 1500. That is the limit for us. Means our flat will contains only 1200 SFT, 1500 SFT. Like this here also at the CPU level, memory level, disk IO level, for each container we are allocating okay, C groups. So I'll tell one example. Even on the VM, also on the hypervisor level, say if you choose T2.micro, what is the like limits you are getting? One virtual CPU and 1 GB RAM. Say here that is at the hypervisor level, but this is at inside the kernel itself. For each like a container, we are allocating the resource limits. So which feature of Linux is supporting this? C groups. The namespaces are providing the isolation and the C groups are providing resource limits. So with these capabilities, we can create an isolated environment in the cloud, sorry, in the Linux server or Windows. But these are the Linux concepts we have. And in the C group also we have the C group 2. And what it is doing is it is controlling the how much limits we can give for CPU, how much memory. So this controlling even at the container level also. This controlling at the container level also we are going to control this. Okay. So any doubts on this?
Clear.
Okay. So using these concepts itself internally that on the same server, it's almost a isolated environment. It's almost the isolated environment. The containers are running. Okay. So now here we have the C groups. Okay, so using that C groups, like now the modern distributions, we have C groups version 2. Okay, so even more like better improved like memory tracking, IO tracking, all those can be done. Okay, so now here namespaces are providing the isolation and one container process can't interact with, all are in their own like rooms kind of thing itself. Okay, so now like Docker, Podman, LXC, there are a lot of containerization solutions. So now in the market, people are assuming only containers are Docker only. It's not correct. There are a lot of container solution, lot of container orchestration kind of solutions. In this, Docker is one of the popular container runtime engine. Okay, and on top of that, we have the orchestration, that is the Kubernetes. Okay, so what is the concept of orchestration is automatically we can scale up, we can scale down. Okay, so then we can increase more resources or we can decrease more containers, we can increase, attach to load balancing, destroy all those. As a single shot, we can do all these. That kind of solution is called as
Orchestration.
orchestration. For that, we have Kubernetes is one of the leader. And next solution we have is one more solution we have, that is called as Docker Swarm, OpenShift. Like this, we have a lot of products are there. Okay, so what are those solutions? We'll discuss. Okay, so now in order to use the container orchestration, one container engine is required. So in our scenario, we are using Docker, but if Kubernetes want to work, one container engine is mandatory. One container engine is mandatory to run those. So then coming back to, so what is Docker? Okay, so what is the concept of Docker is? Docker is one of the open source containerization platform. So just like I'll tell, say suppose normally in the database is the general term, but we have the lot of databases like RDBMS, we have Oracle is there, or MS SQL Server is there. All these are the databases itself. Like this here, containerization is the technology. In this, the products are, so Docker is one of the product which supports containerization. So hence Docker is an open source containerization platform that we can build, ship and run applications. So as a lightweight and portable containers we can run. So when the Docker came initially, they supported Linux. Later they supported even Windows and Mac also. So just like Unix itself is not supported. Okay, so now here we have the concepts is like in the cloud, if you are talking, we have the instance, right? Here in the Docker, we have a container. the running state of that, or maybe executable kind of package. And just like your instance is running, here the container is running. Okay, so that container will have a code, runtime, libraries, settings, all this, and it's an executable kind of thing. Okay, and from where, say, suppose normally our instance is launching from an AMI, right? Say here in the same way, we have an image. We have an Docker image. The running state of the Docker image itself is the container. Okay, and in order to run this, we want the Docker engine, and we are getting a read-only template or maybe blueprint kind of thing. From that, our containers are executing. Okay, so then in order to create the Docker files, we are going to use in order to create the Docker images, you can use the Docker file. We'll discuss all this. Now, what are the advantages of using the Docker? All the containerization benefits will get: portability, isolation, efficiency, speed, consistency, like easy to manage, scalability also we are going to get. Now for the microservices and even for the application sandboxing to isolate that, cloud native development, and for test dev environments, integrating with the CI/CD pipelines, containers, microservices, okay, orchestration, like these are becoming like a modern approach for the application deployments. Okay, but we have a lot of competitors at the container level we are discussing. On the container orchestration also, Kubernetes is the leader, but even we have good competitors for those also. So these all the competitors are for Docker level. So now Red Hat having Podman, this is also one of the popular containerized kind of thing. Okay, so but then we have container D is also one of these. Container D, CRIO. CRIO is developed by Google itself. Then LXC, LXD, these are mostly with the Linux we have. RKT, that's Rocket is called. Okay, that is also we have. So Run C is there. Okay, so these also different, but container is not a, sorry, Kubernetes is not a containerization solution. It's an orchestration kind of thing. And we have open VJet also, Singularity. Okay, so these all the different containerization. Among these, which is the leader, which is the leader, Docker is the leader. Among these, all the solutions, the Docker is the leader for this. Okay. So now coming to the Docker components. So mainly we have the three components we have. One is Docker client, then Docker host or Docker daemon, then we have the Docker registry. So what are the three components? One is Docker client or Docker CLI we have. Second one is
Docker daemon.
Docker host or Docker daemon. And third one is Docker registry.
Registry.
Okay, say in the Docker registry is nothing but it's a Docker hub having all the images. Okay, so normally in the AWS itself we have all the AMIs, right? Say Terraform also have Terraform registry where we have all the providers, all these. Now here Docker registry, in our scenario we have Docker hub. Okay, so in that registry we have all these images, and from the Docker client we are pulling those. Docker client is nothing but a CLI tool, which is normally in our environment in the Linux machine itself. We have both Docker client and Docker engine or Docker host we are running. Okay, so the images are pulled from where to where? The images are pulling from where to where? The images are pulling from The images are pulling from the Docker registry to Docker mission. It's pulling. What is the command is Docker pull. Okay. So what is this happening? We'll discuss. But by default, where all the images are stored, where all our images are stored in the Docker hub. Okay. Or that itself is called as Docker registry. Okay. So now here, we have Docker CLI, Docker engine we can call, or host, or daemon. Then we have Docker registry. In our scenario, we have Docker hub. Okay. CLI is nothing but like normally in the Terraform also we'll use Terraform init. All these, what is the CLI is? Terraform itself is the CLI tool. In AWS, we are using AWS CLI command tool, right? Here, what is the Docker CLI tool is Docker. When I run that, say suppose Docker pull, okay, or Docker search MySQL, okay, then where it is searching that MySQL image, Docker is searching in registry. Normally, even in AWS also, you'll go to AWS instance creation, you'll search for the images, right? You want Windows, NAT, like this we search it, right? It list all the images. So now here, the command line itself, this MySQL image where it is searching in the Docker registry, it is going to search. Okay. Then if I use Docker pull MySQL, then what is going to happen? If I use the Docker pull, okay, say it is pulling this image from registry to locally, it is pulling. Okay. So that is the image itself. We can run that image as a container. Okay. So using Docker run command, that image we are creating as container. What pull is doing is just it's downloading from where to where? Where to where it is pulling? From where to where it is pulling? From Docker hub to from Docker hub to locally it is pulling. So locally it is pulling. We'll discuss this practically. Say if someone asks about what are the like components we have in the Docker architecture, very simple client server kind of architecture. We have a client, then Docker host, then Docker registry we have. Docker registry is nothing but a hub kind of thing where we are storing all the images, registries, all those. Okay, so we are interacting with the Docker using the Docker command line, that is the CLI. Okay, so then Docker daemon is the engine where it will create the containers, will manage the images, volumes, networks, deletion. All these we can use that life cycle of the containers, all those we can manage through Docker daemon. Okay, then here what is the meaning of Docker images? Images are the read-only templates to create our containers. Then Docker registry is also, we are going to create our own registry. From that, we are going to download the images. So now here in AWS also, instead of Docker Hub is by default a public registry. For AWS, we can use ECR, Elastic Container Registry. Google have Google Container Registry. So like this, which registry you want to use, that we can use. And we can pull or we can push the, we can pull or we can push the images. So we can pull or push the images. Okay. So then the running state of that image itself is called as container. The running state of that itself is called as the, okay. So now here we have a difference between image versus container we'll discuss. So which is static, which is dynamic? So which is static and which is dynamic in this? Just like as a read-only file kind of thing is image, but container is a running state. Okay, so container is the running state kind of thing. Okay, so now here Docker file, like in order to create the containers, all the instructions and the blueprint is just like a template kind of thing. Okay, but it's not a complete OS template just like AMIs, but it's having the application code, libraries, dependencies, configuration files. Okay, and that image we can build it from Docker file. So now what is the purpose of Docker file? We can create the images from Docker file, and we can run those as the containers. So now here it's a snapshot or maybe a blueprint or a template kind of thing. Okay, so to create our own application environment, we have the image. Okay, so then one image says the same kind of diagram we have seen in the AMI also. One AMI, multiple instances we can create, right? Here one image, Docker image, we can create multiple containers also. So we can run the multiple
Containers.
containers also we can run, depends upon that. It's the same image. Say suppose Nginx, maybe there may be some millions of downloads from the registry, and everyone are running their own containers. Okay. Then how we are going to create that image also is from the Docker file. We can create the Docker image, and when we run it, okay, so that is going to be container. Okay, a runtime instance of the Docker image, and where we require CPU and memory at the image level is required, or at the container level is required.
Image.
No,
Container level.
container level image doesn't required.
Okay.
Image doesn't required. Okay, for the container level we want the CPU and memory.
That will be shared with the
Yeah, it's
kernel
shared by
only.
the host itself. That shared. Okay, so suppose my Linux machine have one CPU and 1 GB. Maybe we have like a 0.25 kind of CPU, then 200 MB of the like a RAM. Like this, it's going to share that. The host resources itself is shared. Okay. Then can you tell me what is the name of the like what this command is doing? Docker run -d. This command is creating a image or container. That command
Container.
is container. From the image is Nginx. Okay. Even while creating an instance, you'll give the Ubuntu or Windows Server, Red Hat. Like this will give right here from this Nginx, and we given just one name. What is the name of the like
Web server.
uh, container we given there?
Web server.
Web server. That is just in the instance also will give one like a tag, right? Name tag.
Yes.
So now here, can you tell me what is the image?
Nginx image.
Nginx. Then in the Ubuntu also we have 2204, 2404, Windows also 2016, 2019. Okay, what is this meaning of latest is
Version.
Nginx latest version you download. Even if I don't use latest also, that always uses the Nginx latest itself it is going to use. Nginx latest only it is
It will
going to use. Okay, so this is going to create a image or container.
container.
Container. How we can create the images? From where we can create the images?
Docker image.
From the Docker file we are creating. Okay, so that we'll discuss later. First, we'll use the existing images. From that, we'll create the containers. Okay, so now here static kind of thing is the image. when we running state we gave, that's going to become a container, and blueprint of that template is going to specify, and running instance we are maintaining, and from the Docker file we are creating the image, and from the image we are creating a container. Okay, so it required only like a file kind of storage we required, just like you want to copy a ISO kind of thing like this. Okay, so then here this would be existing while running. So CPU and the host resources, all that it is sharing also. Okay, so then we need to install, if you go for the Ubuntu, sudo docker, sorry, apt update, sudo apt install docker.io. What is the package name? These all the commands everyone install. Then if you see the docker sudo as of now use, how to avoid that we'll discuss. Sudo docker info, okay, say info command, then sudo for every command, it's mandatory. As of now, we can discuss how to remove that also. Say sudo docker search MySQL or docker search Nginx, what it is doing from the local machine to, it is searching those images, which are the images are available in, what are the
Register.
images are available in the Docker registry. Okay, so then here we can use Docker, like maybe pull that. Okay,
Sir,
Docker.
rather than using this many sudos, can we not first switch to the sudo switch user minus first and then start using?
No, never use root user.
Okay,
So as per the security and as per the DevOps process, say don't switch to root user.
okay,
Say AWS also, that's always not recommended. Whenever you want, you just escalate sudo.
okay.
So directly don't switch to
Sudo.
sudo. That is not a best practice. AWS also directly can give the root access for us, right?
Yes.
So that's not a best practice to do. DevOps wise or security wise. Okay. So
Okay.
don't provide the root access. Okay. So then what is that Docker pool Nginx is doing?
It's pulling the Nginx image from
Nginx
register.
image it is pulling. Okay. So then I want to run that sudo docker run. I'll explain what is this publish port also. If I don't give here also, it's download the latest one itself. Okay. So then what is the name of the container I gave here? What is the name of the container I have given? What is the
My
name of my
Nginx.
Nginx? Okay. And what is the image? What is the image here?
Nginx image only.
Nginx. My Nginx is the container name. Container name is my Nginx. Image name is Nginx and that version is latest.
So
That version.
minus D is detached mode.
Yeah. If I don't give -d, okay, your container is running in the foreground itself. If I don't give, okay, it would be
Minus
running in the
foreground.
foreground in the production, not recommended. Hence, we are using detach mode. In this, that container is running in the background.
Okay.
So
So
if I
that we
don't
can
use that, it would be running in the foreground itself.
foreground. Okay.
Okay, that's not recommended. Make it running as a background. We are using in the detach mode.
Okay.
Okay, so some of the containers you just don't use hyphen D also. And hyphen P is used for publish port. Hyphen P is for publish port. So what is that publish port also? We have two ports, 80:80, right? That is also we'll discuss. Using that port itself, we are going to expose our application. Okay, so like this we can run it. Then can you tell me Docker images will display what? Locally, what are the images we have? Okay, with which command the images will come locally? With which command the images will come locally downloads? With the Docker pull command that is going to happen. With the Docker pull command, it is going to download locally. Okay. Then it is Docker what is the Docker images is showing?
The images that we have locally.
Locally, what are the images we have downloaded that is showing. Okay. Then Docker PS. So what is the Docker PS will show is all running containers it displays. What is the meaning of running containers? If the containers are stopped or exited, PS doesn't display. Even in the instances also, if you keep a filter running, some instances stop would state, those we can't see, right?
Yes.
So that means PS will display only the PS
Running
will
container.
display only the running containers. Okay, if I use PS hyphen A, okay, it displays all containers. All containers means additionally what we are getting? That containers may be stopped or that containers may be exited, okay, passed. These kind of containers also would be displayed in PS hyphen A. But PS will display only PS will
Running
display only the
containers.
running containers. Whereas PS hyphen A will display all containers. Okay, then Docker, like in the PS, like every instance will have an instance ID, right? Okay, now even for every container also, for every image also, we'll have the image IDs and container IDs also. Then if I want to delete one particular container, then Docker RM, okay, then that container ID or container name we are giving. So that means while creating a container, what is the command we use to create the container? What is the command we have used?
Docker RM.
No, no. To create the container, what is the command we have used?
Docker run.
Yeah, Docker run command is creating the container. Docker
Run
run is going to create the
container.
container. Okay, so then what is Docker RM will do?
Delete.
Will remove that container. RM will remove that container. But RM if I use, it will remove only stopped container. If container is running, we need to use hyphen F option. Hyphen F stands for
Force.
force. So even if I don't give a name also, ID will come. Okay? So I hope you understand, right? What is RM? Then what is RMI?
Remove images.
Yeah, we can remove the images. By using the RMI, we can remove the images. Then that image ID or name we need to give. I have a doubt here whether that locally it's going to remove that image or from the registry it's going to delete that image.
Locally, I guess.
Locally only, not from the registry. Okay, so locally that image is getting deleted. Okay, so what is that? Like to stop the running container, to remove the running container, what is the command? To delete the running container, what is the command? Docker rm like Docker rm that container ID, then hyphen f you need to give. Hyphen f we need to provide. Okay, the RMI is for image. So stop, start, all these are the instance level we done, right? Stop, start, delete, terminate. Same thing here, we have a container level life cycle. All these days we have the instance life cycle. Now we have even at the container level life cycle also all the commands we need to understand. Okay, even we can do the restart also. Then these three, like tomorrow I'll explain inspection, commands, all these.
Sir, any day, sir, Docker.
Yeah, we'll see. I shared that those also go through, then we can finish fast. Because for Kubernetes, Docker is the prerequisite.
Sir, share the text file if possible.
Sure, sure. I'll share that. Okay.
Sir, this file also, sir.
Yeah, yeah. What is Docker file? The Docker file, we have the instructions how to build an image. Okay. So that means even in the real time also, the mandatory skill the DevOps engineer should have is for our application microservices, we should able to write the Docker file. The Docker file is a simple text file which is having the instructions. From that instructions, we can build our own Docker images. And once we got the images, we can run them as the containers. And on top of that, we can orchestrate also on the Kubernetes or Docker Swarm or OpenShift, this kind of orchestration tools also we can orchestrate. But we want the image. Okay, that images how we are building
Docker file.
Docker file. That the Docker file have the set of instructions, and when we start the Docker build, okay, so our images are getting builded. Once we build the images, we'll save those images. Okay, where we are going to save them? Not locally, in the
Registry.
registry we are using. For that we have Docker Hub, or in AWS we can use
ECR.
ECR or ACR, Azure Container Registry, or
ECR.
GCR, Google Container Registry. Locally, we can keep even in the private also, DTR, Docker Trusted Registry. So from that, we can do the pull operations or push operations. What is the meaning of pull? From the registry to downloading, push is doing what push is doing. Pushing the locally created container image, we can push to
Registry.
T. Okay, the pull is from the registry to locally we are downloading. Okay, so in the CI/CD, first we'll push that image to registry. Then anyone can download that and they can pull it and they can run that. Okay, so run is doing even pulling also. Okay. So technically run can do pull also. That means when I use the Docker run, it is going to search that image locally. If that image is not existing, what it is going to do? It will pull that. Okay.
Got it, sir.